I usually just hop into the benchmarks, but I think it's very important that we point out that this comparison is not exactly fair from a price point of view. This is comparing the best AMD has to offer so far from the 7000 series, the best Nvidia has to offer from the 4000 series performance-wise, but pricing-wise, they're just not even close. The 7900 XTX is coming in at a $1,000 MSRP, and on the actual market has been available closer to $1,200 at the time of filming, but we'll see what happens as more supply batches start to come through, all of that. And the RTX 4090 is supposed to MSRP around $1,600, but actually sells for around $2,000 or more on the actual market, so keep that in mind as we hop in. Now, if you're watching this video, you're probably interested in the highest end gaming hardware, and I've got to tell you about a phone that actually is just launching today as of the time of filming. You're actually probably super interested in this if you're into gaming. When my students saw me playing games on my phone today, between classes, not during class time, don't panic, they were so incredibly jealous. This is the Red Magic 8 Pro gaming phone, but it's a great phone and a great gaming phone. That's what I'm so excited about it, because first of all, it's just a beautiful like AMOLED full screen display, underscreen camera with no notch, and then you flip this switch, it goes into gaming mode. Now you've got these shoulder triggers, and that's what was life-changing for gaming on my phone. I used to hate playing first-person shooter games on my phone like COD Mobile because, okay, I can move, I can aim, but now if I want to also push some buttons, it just feels horrible. Now I can just program, you can program these shoulder sensors to hit anywhere on your screen that you want. It's customizable game by game. So now I can aim down sights and shoot just like I was playing on a controller. Feels great. My students were so jealous. They saw the cool RGB cooling fan. They were like, what is this phone? It's the Red Magic 8 Pro. There's so much more I'd like to tell you about it, including like the excellent battery life. I've been using this thing all day, including playing games on it, watching videos on it, whatever, scrolling the internet, and I'm still at 79% battery life. So much more I'd like to tell you. Check the link in the description. Check out the Red Magic 8 Pro. Let's back to our normal programming. Back to the GPUs. The cooler model we're looking at is the 7900 XTX AMD reference model, and mine does not seem to have the 110-degree hotspot issue that some reference models do have. And remember, the custom card variants do not seem to be having that issue, so don't need to worry about that on those. And then my RTX 4090 is the Gigabyte Gaming OC, and I'm running both of them at their out-of-the-box settings. Let's hop into the benchmarks. Many new AAA games will be using Unreal Engine 5 in the near future. And right now, Epic's own Fortnite is the first game to implement it fully in a released product, and it uses the new lighting system Lumen, which is a software-based ray tracing. It has Nanite, which allows the smooth, fading in of objects that are compatible with it, so you don't get all the LOD pop-in, things like that. It looks great. It also has a hardware-accelerated ray tracing option, which looks a little more accurate and is a bit more demanding, and I currently have that turned off, although we will definitely try turning it on. And here we're seeing the RTX 4090 only delivering a little over 60 FPS, and the 7900 XTX actually down in the mid-40 FPS range, and the RTX 4090 delivering about a 38% lead by the end of the benchmark run at these settings. So yes, Fortnite is this demanding now? And what does that mean for, future Unreal Engine titles? And what if we turn on hardware-accelerated ray tracing? We know that Nvidia has the lead in hardware-accelerated ray tracing, so what's the difference here? Well, now we see the RTX 4090 leading by 49% rather than 38%. And we also see the RTX 4090 dipping below 60 FPS a lot more frequently here, although it didn't make a massive difference to the overall performance. And we now see the 7900 XTX averaging closer to 40 FPS rather than in the mid-40 range. So the hardware RT in this game isn't incredibly demanding, but it is definitely taking them both, down to frame rates we probably wouldn't want to hit. So I also wanted to look at, what if we left it completely maxed out, so 4K Epic settings, hardware RT on, but then we decided to upscale. Now, this game does not currently have DLSS or FSR implemented, although the engine will support that, but it does have Unreal Engine's own temporal super resolution, TSR. I've set it to the quality setting, which is a 1440p render, which is then using temporal data and such, similar to DLSS and FSR2, and upscaling to give you a 4K-like image. Now we see the 7900 XTX over 60 FPS and the 4090 over 80, and the 4090 with about a 35% lead at those settings. But what if we don't want to upscale? What if we want to actually play at 4K? Well, what if we just drop to the high preset rather than the epic preset? And what if we turn the hardware accelerated ray tracing off? Then the 7900 XTX is actually giving us around a 60 FPS experience, and the RTX 4090 is delivering over 80 FPS much of the time, and it has about a 31% lead at these settings. Now remember, not every game that uses Unreal Engine will be equally demanding, but I would actually imagine many would be more demanding than Fortnite because it's targeting 60 FPS on consoles with upscaling and all that. But some games that end up targeting 30 FPS on consoles, it'll be interesting to see how that plays out on PC hardware with the settings cranked. Anyway, what if we use the high preset and upscale, so TSR quality, which might be more similar, not exactly the same, to what a console might run. Now we see the 7900 XTX over 100 FPS, the 4090 over 120 FPS, and the 4090 is only leading by 18% now, but I think we're actually hitting a bit of a CPU or RAM limitation, something like that, because the frame rates on the RTX 4090 just... I think that explains why its lead diminished at these settings. It's also diminishing a bit at 1440p, which I wanted to look at next, because you can certainly look at these cards at 4K, and that really helps the GPUs like the 4090 stretch its legs as far as it can. But 1440p is still a more popular resolution, and we can see the 4090 dropping a bit in power consumption and usage at times, so its lead is only about 26% here. The 7900 XTX is averaging almost 80 FPS, and the RTX 4090 is averaging in the upper 90 FPS range. So it's looking like, good settings at 1440p with high refresh rates in Unreal Engine 5 is definitely doable by both of these GPUs. But what if we turn on that hardware accelerated ray tracing? So now the lead for the 4090 does get extended to 34%. So, it is definitely true that the 4090 is better at hardware accelerated ray tracing. Now, keep in mind, other games push ray tracing very differently. So if you're just skipping now from the video like, okay, I've seen enough, keep in mind that I'll test out other games with ray tracing. We'll see different results based on the type of ray tracing implemented at these settings. The 7900 XTX is in the mid 60 FPS range, and the 4090 is at almost 90 FPS, and again with about a 34% lead overall. Now, let's test out some other games, because not every next-gen title is going to be using Unreal Engine, and this is Plague Tale Requiem at 4K Ultra, and we now see the 4090 with a 27% lead over the 7900 XTX. The 7900 XTX averaging in the mid-60s through this opening cutscene, but in the more demanding areas, it'll be below 60 FPS on the 7900 XTX. The 4090 averaging over 80, but in this scene in kind of the mid-70s. And this is a custom engine developed by this developer, and this game looks absolutely beautiful, and it pushes consoles very far. What I mean by a next-gen game is one that's not trying to go cross-platform to like the PS4 and Xbox One and all that. Now, Plague Tale Requiem is an Nvidia-sponsored title and does feature DLSS 3 frame generation. So here you're seeing the 4090 versus itself with frame generation plus DLSS quality versus 4K native, and we can actually see that 4090 can go over 150, 170 FPS here. However, these frames don't always look equivalent to native ones, and also they don't help your input latency because the AI-generated frames are not interactive. I've done a whole video on this. It's a good feature, and I really liked it in this game, but comparing these frames apples to apples against non-frame generated frames really is not a fair comparison. So see my video on that. And this is the only game in my benchmark suite that happens to support frame generation. So there's you look at it here, watch my full video on that. If we go to 1440p Ultra, we now see the 4090 leading by 22%, and both GPUs delivering over 100 FPS easily, 125 average on the 7900 XTX, and over 150 average on the 4090. So at 1440p, they're both absolutely crushing it, no problems whatsoever. Especially in a single-player game like that. But moving on to some multiplayer, Here we see the 4090 with only a 7% lead. What is going on here? Well, this is Call of Duty Modern Warfare 2, and we are at the 4K extreme settings, not because lots of people would be playing a competitive game at those settings, but this is to remove as much as possible any kind of system bottleneck from the CPU or RAM or any of that. So yes, this really is the 7900 XTX almost tying the RTX 4090 at a significantly lower price. And I think when people watched the first announcement, this is what people wanted from the 7900 XTX, but they only get it in Call of Duty Modern Warfare 2 or Warzone 2. Now, that's still a great thing because this is a very popular game, and there's many people who play like one multiplayer game. If this is your game, AMD GPUs, and this is across the board, this isn't some fluke, in this game, AMD architecture just dominates. I'm not sure if maybe a driver update could help that in the future for Nvidia, but this is what it is. And guys, if we drop it down to the 4K balanced settings, so obviously playing competitive games at 4K, you might be somebody who plays single player and multiplayer games. This is like me. I'll play 4K competitive games because I have a 4K screen. And if I just turn down the settings to balanced, both of these GPUs are delivering us, in actual gameplay like this, 200 FPS much of the time. So it's still pretty competitive. But now we see the 7900 XTX. I mean, it's basically a tie, but the 7900 XTX is up 2% by the end of the benchmark. And I'm not 100% sure there. I mean, we have seen it be closer at 1440p frequently. I've also noticed that AMD GPUs, when they do get any sort of a CPU limit, it often happens at a higher frame rate than the Nvidia counterpart, suggesting a difference in driver overhead or something like that. Now, I'm not seeing a lot of signs of a CPU limit going on here or anything. But anyway, 7900 XTX, pretty much matching the RTX 4090 at 4K in this game, and now dropping down to 1440p at the balanced preset. So notice this is not the extreme preset. I think we do actually see a bit of CPU limitation coming in at times. And the 7900 XTX is pulling ahead by 15% at the end of this benchmark. And again, I don't, this is not incorrect. This is correct. But again, don't take this as typical, of the rest of the benchmark suite, but it's very interesting. So if you are a player who, like I said, a lot of people focus on their multiplayer game of choice, they might play some other games, but this is what they really care about chasing the frame rates in. Here's your big selling point. 7900 XTX is beating the 4090 by 15% on the same system here. Like I said, it could have something to do with pulling ahead with in the CPU limited situation, or just this game, but it's a 300 FPS versus 250 FPS. Anyway, let's move on to another game. So Cyberpunk 2077 at 4K ultra settings. In the previous generation with AMD's 6000 series and Nvidia's 3000 series, there was no GPU that could average over 60 FPS in this benchmark at stock settings without upscaling at 4K Ultra. Well, both of these do it. The 7900 XTX is well over 60 FPS most of the time, and the RTX 4090 is over 80 and even getting into the 90s pretty frequently throughout this benchmark run. Now, actual scenes in the game can become more demanding than this particular benchmark scene, although that early bar scene at the beginning of it is pretty demanding. But we do see the RTX 4090 with a 25% lead here. So the 7900 XTX is closer to the 4090 in this game than it was in something like, Fortnite and Unreal Engine 5, that kind of a thing. But the 4090 is still with that 25% lead, both of them doing well overall there. You can see the stats at the end of the benchmark run and pause there if you'd really like to. But I'd also like to mention that both GPUs can actually deliver a high refresh rate 4K experience in this game if you're willing to tweak the settings a bit. If you go down to the high settings instead of ultra, you gain a pretty significant chunk of performance. And if you use DLSS or FSR2 at the quality setting, which renders the game at 1440p and then uses some really high quality temporal upscaling to render an output that looks pretty close to a native 4K image, we can now see the 7900 XTX well over 100 FPS average and the RTX 4090 averaging over 150 FPS. And actually, as we get into this little populated city area, we'll even see the GPU utilization drop a little bit, especially on the 4090, because you actually get a little bit of a CPU limit. The frame rates are so high at these settings on these GPUs, but still a 36% lead here for the 4090, but both of them delivering a high refresh rate 4K experience until you turn on ray tracing. Now, here's where we're going to do a bit more of an in-depth look at the ray tracing performance of these GPUs. And it varies wildly based on the ray tracing settings that you select. Here we've selected the RT Low preset. So it's the Ultra preset plus ray traced local shadows. Just the local shadows, none of the lighting, none of the sun shadows, none of the reflections. We can see here that the RTX 4090 is 41% faster than the 7900 XTX. Remember, at just using the Ultra preset, it was 25% faster. So it's certainly gained in performance relative to the 7900 XTX using the RT Low settings. But, you know, compared to what it was before, it's not just like a massive change from what we saw before. It's noticeable, but not incredible. In other words, AMD's hardware can handle some low ray tracing settings relatively well. Now it's averaging, the 7900 XTX is averaging below 60 FPS at these settings, so in reality you might be interested in upscaling, that kind of a thing. But if we decide to crank the ray tracing settings, we see a whole other result. And honestly, for both GPUs, Cyberpunk at the RT Ultra preset just crushes GPUs, especially at 4K. And even the 4090 here is only averaging well below 60. In this bar scene, it's dipping below 40 at times. 1% low is only a little over 30, whereas the 7900 XTX is just completely unplayable, averaging below 20 frames per second throughout that bar scene. Now, to get the relative performance, I'm using the native settings here, and we see that the 4090 has 220% of the performance of the 7900 XTX, or in other words, a 120% lead. It's more than doubling the frame rate. However, both GPUs can give us playable experience here, but the 7900 XTX has to upscale from 1080p using FSR2 performance, and DLSS quality on the 4090 actually gets you over a mid 70 FPS average, and the 7900 XTX is still below a 60 FPS average with those settings. So now if we go down to 1440p, we get much more playable results from both GPUs. Now on the left, we're seeing them at the native resolution, and on the right, we're seeing it with FSR2 and DLSS2 at the quality setting. Now, my relative percentage difference here is based on the native settings, and we see the 4090 with a 110% lead, or again, still a little more than doubling the performance. And the 7900 XTX is not delivering particularly high frame rates here, averaging below 40 FPS for much of the run, with the 4090 averaging over 80 FPS for much of the run. However, using FSR or DLSS2 at the quality settings, we do see the 7900 XTX averaging over 60 FPS through this run, and it doesn't look too bad with FSR2 quality, and the 4090 is now averaging well over 100 FPS. So it's, it's really interesting. The kind of results you can get here. Although honestly, the 7900 XTX does have ray tracing performance, and I've seen this in other videos, similar to a 3090, so or a 3080, depending on which ray tracing setting you use. So again, investigating the difference between the ray tracing ultra versus ray tracing low, and now even ray tracing medium. Look at the percentage differences and how they've changed, right? So this is at 1440p, and this is native resolution now. With the RT low settings, the 4090 is only winning by 37%, whereas with the RT medium settings, it's winning by 72%. Now, RT low just has the local shadows. RT medium has local shadows, sun shadows, and a medium lighting setting with none of the reflections. The ray traced ultra setting, where we saw the 4090 more than doubling the performance of the 7900 XTX, On those settings, it also has all the shadows, but it also has ray traced reflections and turns the lighting up to ultra. It actually doesn't go up to psycho on the lighting, which you can set manually. So you can see that depending on how heavy we go on the ray tracing, the relative performance difference between the GPUs is all over the place. So that's what I wanted to look at now here, is now isolating the ray traced reflections, because that's one of the ones that AMD really seems to struggle with in this title. So here we're seeing, and also this gives you a chance to look at the ultra settings at 1440p versus the ultra plus ray traced reflections settings on the right hand side. So at 1440p ultra, the 4090 only has a 23% lead over the 7900 XTX. Whereas if you have ultra plus the ray traced reflections, the 4090 has a 69% lead over the 7900 XTX. However, I will mention that the 7900 XTX is averaging over 60 FPS using 1440p Ultra plus ray traced reflections. It's just the fact that the RTX 4090 is averaging well over 100 frames per second. But both of those are doing it at the native resolution. So I do think the 7900 XTX does deliver usable 1440p ray tracing performance that's on par with high-end 3000 series Nvidia GPUs, but the 4090 just outclasses that pretty significantly. But do keep in mind the pricing difference is also huge. So these are not evenly priced GPUs. Let's jump into the Callisto protocol. We'll start out with 4K Ultra. And this is an Unreal Engine 4 game, and it's been pretty widely known that NVIDIA GPUs tend to outperform the average, performance deltas versus AMD in Unreal Engine 4 in the previous generation, and we're seeing that here as well, with the RTX 4090 with a 62% lead over the 7900 XTX in the Callisto protocol at 4K Ultra, even though this is an AMD-sponsored title, actually. But, Plague Tale was a NVIDIA-sponsored title, and the AMD GPU was kind of catching up there. Anyway, relatively so. Whatever. Anyway, if we go down to 1440p Ultra, we see the 4090 with only a 38% lead, which is more typical, but also if you look at the GPU utilization percentage, the 4090 is getting some CPU limits here, RAM limits, or something going on with the engine, because it's not near 100% utilization much of the time, explaining that why the gap dropped significantly, dropping from 4K down to 1440p, just because the 4090 seems like it would be capable of more if the rest of the system could keep up. Now, if we enable some ray tracing, we see the 4090 only leading by 35%. Wait, shouldn't its lead grow when we are enabling ray tracing? Well, I think the 4090 is capable of a larger lead, but we can see, again, the GPU utilization of the 4090 dropping significantly at times throughout this run, showing that, a lot of people don't realize it, but enabling ray tracing does increase the CPU load, and this game seems to do it in a very non-multi-threaded way, meaning it's very easy to become, I think it's a CPU limitation when you enable ray tracing in this game, even at 4K, and that's holding the 4090 back from even bigger leads. And to further emphasize that, if we turn on FSR2 quality, this game supports FSR but not DLSS, but both, NVIDIA GPUs can use FSR2, so we're using it on both here. We see that the overall frame rates get a lot better for both GPUs, but now the 4090 is barely ahead, and it's basically a tie of the 7900 XTX. But again, look at the GPU utilization, where we see the 4090 not at all fully utilized throughout this run, showing that it's held back by something with the rest of the system or the engine or whatever. And that's explaining why they're coming out so close in that test. And it also explains why if we go down to 1440p and we enable ray tracing max on top of the Ultra preset, we actually see, again, basically a tie, but the 7900 XTX with a 5% lead. Now, again, in some of the places where they both seem CPU limited because they're not being fully utilized, you can see that the 7900 XTX hits that cap at a slightly higher frame rate, giving it this lead. And again, that could be a driver difference or something with the amount of CPU overhead that goes on. It's a little difficult to fully explain, exactly what's going on there, but that would be my guess. But anyway, let's take a look at some other games. Let's do a quicker look at some easier to run titles. I wanted to start out with heavy-duty new games, new engines, or just, Cyberpunk is a couple years old, but it's demanding. Anyway, here's Forza Horizon 5 at 4K Extreme, both of them delivering over 100 FPS. The 4090 with a 38% lead. They're both doing really well here. I will note that you could now enable ray tracing while driving in a recent update, but I don't believe the 4K Extreme preset, which I've selected here, actually does that. I think it... But I'll also mention that the 4090 is frequently down into like the lower to mid 90% utilization range. So even at 4K Extreme, its frame rate is so high here, averaging over 146 FPS, that we might even be seeing a little bit held back by the rest of the system. But again, let's keep jumping around to some other games. I did want to look at a DirectX 11 game. And so that's what we're doing here. God of War at 4K Ultra settings, and this is a relatively recent DirectX 11 title. Both GPUs delivering excellent 4K performance, the 4090 with a 38% lead over the 7900 XTX. And, they're both doing well here. But by the way, the overall average frame rate is higher in that cutscene than what you'd get normally. This scene standing still holding the log is showing current frame rates closer to what you would see in typical gameplay. Current frame rates on the left, averages in the middle, 1% lows on the right, as I usually do here. So let's go ahead and once again look at easier to run games. So Horizon Zero Dawn at its maximum 4K settings, so 4K Ultimate. The 7900 XTX averaging over 100 FPS through the benchmark run, and the 4090 pushing into that 150 FPS average range and showing a 40% lead over the 7900 XTX. This is another game like God of War that originated on the PlayStation 4, although this PC port went with a DX12 version, whereas God of War, like I said, went with a DX11 version, which I thought was a little bit interesting, honestly, that God of War is such a recent game going with a DX11 only release. But let's go ahead and look at Shadow of the Tomb Raider. This is the 4K highest preset. Highest is the name of the preset. This game actually does feature ray tracing that you can enable and turn up, manually. But at these non-ray trace settings, we're seeing the 4090 with a 48% lead. But again, both of these GPUs delivering over 100 FPS, and the 4090 over 170 FPS much of the time throughout this section. Now, the actual full benchmark run is a lot longer than the sequence that I'm showing you just here. And I'm not running the averages or the 1% lows because it goes through load screens, but here's the average results from the benchmark itself that I actually based my final results off of. Now let's take one last look at ray tracing performance. This game features ray traced shadows, and you can set them to a variety of levels. I've just cranked it all the way up. And we can see that the 7900 XTX is actually delivering over 70 FPS much of the time at 4K maximum settings with ray tracing maxed out here, although again, it's only shadows in this game. The 4090 though, usually over 100 FPS, and the 4090 now has a 63% lead over the 7900 XTX. So this is just once again showing that the relative ray tracing performance and the usability of the ray tracing just completely depends on the game's particular implementation of ray tracing. Anyway, let's get some final thoughts. Well, I think the benchmarks have shown that the RTX 4090 is a step above in GPU class compared to the 7900 XTX, and this is a different story than we saw last generation with AMD's 6900 series cards, really toe-to-toe with the RTX 3090 series cards until you turn on ray tracing. Well, for the 4090 versus the 7900 XTX, we are seeing the 4090 winning by, well, a variety of margins. Really, it seemed to depend a lot on the game we were looking at, and something like Cyberpunk 4K Ultra, maybe only like a 25% lead, but in the new Unreal Engine 5 that a lot of people are going to care about, we really only have Fortnite to look at right now, but we did see, more like a 38% lead at 4K, less at 1440p, more when you turn on ray tracing, maybe a 50% lead at 4K. But then you turn on light ray tracing workloads, yeah, maybe it's a 50% lead. If you turn on heavier loads, maybe it's a 70% lead. Really heavy ray tracing workloads, maybe it's doubling or more of the performance, so it's really all over the place. And I'm focusing mainly on the gaming use case of the GPUs, but one justification for Nvidia charging more on their graphics cards is also in productivity. So if you do use your GPU for work, you should think about how well your app that you use supports AMD versus Nvidia. Some apps work fine on both, others just really Nvidia has a larger market share, so the applications, are going to be more heavily programmed, more developer time spent focusing on the Nvidia GPU, although I do know AMD has been putting an effort out this generation to make partnership deals with a lot of relevant applications to try to improve that, and we've even seen apps like OBS now doing the hardware-accelerated AV1 encoding for AMD, so once live streaming sites like Twitch start supporting that, the live streaming advantage for Nvidia could start to fade this generation, but again, a little more time going on that. We also see on the gaming side, the RTX 4000 series already has DLSS 3 frame generation, and AMD claims they'll be coming out this year with some sort of FSR 3, which should do something similar, but we haven't actually got that on our hands to test out yet. And I always recommend buying GPUs on what they can do now, and if they get better in the future, great, that's added value. But I think you should always make the decision on how things actually are now, because that's the only thing we can be sure of, right? Rather than buying future. Now, pricing-wise, what makes sense here? Well, the RTX 4090, as I showed in the intro, if you search on somewhere like PC Part Picker, just sort prices low to high, the 4090s start at $2,000 and go well over that, although there are a lot in stock. That's the pricing that we're seeing for the ones that are available new. Now, if you look at the 7900 XTX, for some reason, a RTX 2060 pops up at $400. But then when you go past that, it seems like a lot of the models on the 7900 XTX have actually sold out, and the ones that are available are well above the $1,000 MSRP. Cheaper ones closer to $1,200, with some going significantly past that. Now, I'm hoping that as AMD gets new batches in and supply increases, that maybe the prices on these would go closer down to that $1,000 price point. But now let's actually start talking about value comparison. And value comparisons get weird when you're talking about GPUs that are this far apart in pricing. Let's start with the MSRPs and take the $1,000 baseline. We saw that in, like I said, Unreal Engine 5, without the hardware accelerated ray tracing, let's call it a 40% lead. It wasn't exactly, but let's call it that. And so if you baseline the pricing that way, then if we multiply the price of the RX 7900 XTX by 1.4, we get to 1400, which means that for the same rasterized performance, the RTX 4090 would need to cost around $400 to match, right, in terms of rasterized performance, if we're calling it a 40% uplift. Like I said, it swung from 25% to 70%. It's all over the place. But in other words, I think for rasterized gaming performance, the AMD MSRP is better value for that rasterized performance. Now, if we set a $1,200 baseline, which is more like what we're seeing these actually cost, then that rasterized performance uplift, if we scaled for the same price to performance, would cost you closer to $1,700, but we are still seeing the RTX 4090s costing more than that, closer to $2,000 on the market. So even at the actual prices we're seeing on the market today, for rasterized performance, the 7900 XTX does seem to be offering better value. But like I said, that's not the only thing that comes into play. In light ray tracing workloads, like we saw in the Unreal Engine 5 example, And we saw maybe a 1.5 times advantage. That would get up to an $1,800 price to performance swing if you bought the 4090. In other words, it's still a little bit, the ones on the market at $2,000 are still a little overpriced for an even scaling. But once you start getting into heavier ray tracing workloads at a 1.6 times advantage, that's where you start getting where the $2,000 is about the same price to performance. And then we saw in heavy ray tracing workloads, the RTX 4090 can be twice as fast or more, which would then value that at $2,400, but that's just in heavy-duty ray tracing workloads. So, the price scaling is all over the place because the performance scaling is all over the place depending on what you're doing with it, right? And again, productivity apps, all of that could play in. So I guess what I'll say here is that I think if you're using mostly rasterized performance or light ray tracing, the 7900 XTX does seem to be better gaming performance value. But if you're going to be using heavier duty ray tracing, the 4090 does seem to start to at least be similar performance per dollar, and possibly better if you're like really cranking the ray tracing settings. Now, like I said, I do think other features add value, and in general, the RTX 4090 really doesn't have a direct competitor, right? The 7900 XTX isn't a direct competitor, and usually the highest end product with no direct competitor doesn't offer the best, value per dollar because there just isn't anything pressuring it. So it would be cool if we did eventually see some kind of update from AMD this generation, although it does look like the 4090 isn't using its full GPU die, and there is room for a 4090 Ti or something like that too. So it'll be interesting to see how this thing plays out in the future. But where it stands now, I guess what I would say is this. Think about what resolution you're playing at, because one thing we did see was that even though I have one of the fastest CPUs on the market with the 7700X from AMD, one of the fastest gaming CPUs, the 13900K from Intel, depending on the game, can take a lead. But on average, they're fairly comparable with a slight lead for Intel there. But what I'm saying here is even on one of the fastest gaming CPUs on the market, at 1440p, the 4090 can certainly be held back to the point to where it has a smaller lead. So then the 7900 XTX might make a lot more sense. So if you're gaming at 1440p, do you really need the performance from the $2,000 RTX 4090? Now, do you ever really need that performance? ? Well, at 4K, so if you're on a 4K monitor, especially one that's capable of, 120 hertz, 144 hertz, something like that, then the RTX 4090's extra performance at 4K is certainly something to consider. And we even saw trying to just max out settings at 4K native on, Unreal Engine 5 and Fortnite, which, like I said, I doubt is going to be the most demanding Unreal Engine 5 game that we see in the next couple of years. The 4090 was struggling just to hit that 60 FPS mark without upscaling or turning down settings. So it's certainly not performance that is an unreasonable amount of performance to be shooting for if you're gaming at 4K. So I think what that really is confirming is that gaming at 4K is still very much an incredibly expensive thing if you're trying to max out graphics settings. Although we also saw that if you just turn down settings a little bit and or upscale a little bit, both cards are capable of good performance, but then the 4090 is really can shoot for those high refresh rate 4K gaming experiences once you tweak the settings a little bit. Anyway, what do you guys think in the comments section? Like I said, these are not direct competitors. If you're more interested in the 7900 XTX versus the 4080, I've already done that video, so maybe take a look at that one next. And remember, you could get the Red Magic 8 Pro gaming phone in the link in the description. Guys, it actually really does give me a competitive edge. I suck at Call of Duty Mobile, but like with those shoulder triggers, I've been playing the ranked and like actually just flying through the ranks. Like it's actually, I think, kind of an unfair competitive edge in certain games. I hope all of you have an excellent day.